Okay, so we have just now seen that how to get to W transpose X is equal to 0. Given my W naught is passing to means it's equal to 0, that means my its point is passing through the plane. Now the next thing is, let's say I have a plane and I basically have a vector W which is basically passing through origin and it's perpendicular to this. Now in that case, if I have a point P, so let's imagine that it's an n-dimensional plane. Now if I have a point P, so point P will also be having n-dimensional data. So it is also going to have 10-dimensional data. Now what we are interested to find out is that what is the distance of this point from this plane D. Let's say this is what I want to find out. Now in this case, if I do have to find out this, so definitely since it is passing through origin, it's going to be W transpose X is equal to 0. Here my W is also a n cross 1 dimension matrix, P is also a n cross 1 dimension matrix. If you want to find out this value of D, given that it is passing through origin, the formula for this is going to be WT transpose P given by length of this. This is the formula for doing this. Now this proof I would leave it basically as a exercise for you to do it. If you need any help, feel free to post it on the discussion forum. I would be more than glad to give you some hints for it. But in machine learning, the focus will not be on proof, because proof will go too much intensive, and I really don't want to go into all that. Sometimes it's good to just know some of the mathematical formula which are applicable and basically to use them up. So again, I will give you links if you wish to just post the question, but at the same time I would have a recommendation that please try to do it on your own, to be frank, this is not going to be having much more impact as well. Now on the other hand, let's say basically if you look at this particular angle which is happening between them, this is basically going to be basically theta between both of these ends, right? Now let me ask another question from you. What about if this point P is coming here instead of this? So let me call this as P dash. So P1 dash till Pn dash. Let's say this is my point now. So in this case, what is going to be the formula? So if you think about it, now this W and this point P dash are into two different completely different zone, right? So if you see this point, this is completely in two different zone, what we can see here. So the angle also is going to come like this, like, because remember there is a cos theta term, so the angle is going to become like this, theta dash. So that's the reason this will become negative in this case. So now in this case my value is going to come out to be negative part. So D dash is going to be negative. So WTP means W transpose P divided by length of W, but at the same time the value is going to be negative. So this gives me a very good insight, right? So if basically my point P is on the same side where my W vector is there, then that means I'm going to get a positive points. Otherwise I'm going to get a negative point, right? So this is a very nice way. If I have to kind of put it like this, let's say I have a pi plane, and so if I have W vector being perpendicular to this, and I have some points like P, Q, R and S. So let's say these are the points on the top side. So these if this is coming to be positive, that means they will be on the left hand side of the plane. If let's say I have P dash, R dash, S dash, Q dash coming up, so if my value of this multiplication comes out to be negative, that means they are on the right hand side, this side of the plane. So this is how you can even distinguish your point, and if you think intuitively, this will start making more sense to you once we will start applying all this concept in machine learning. For now, just understand the beauty of maths behind it, which we're going to use it at that particular moment. But I just want you to understand intuitively how these things are happening, so that when you will go and start applying all this concept in machine learning, it will start making sense to us. Now similar way, if I let's say talk about a circle, now you must have heard about a circle equations a lot, right? Now if I talk about a circle, so what I'm going to do, I'm going to start with a circle and then I will take it to ND plane here also. Now if you recall, my equation becomes x square plus y square is equal to r square. This is basically nothing but your radius, right? So that's what I've defined. If I have any point here x and y into this plane, this is going to be this. Now what I can always say is, if my x, if let's say there is a point x1 comma y1, okay, and if I want to find out whether this is inside the circle, outside the circle, on the circle, so I can always say x1 square plus x2 square. If this is comes out to be less than r square, means strictly less than r square, that means that point P, which is basically x1 y1, is going to lie inside my circle, right? So this is basically inside my circle. Similar way, if I say x1 square plus x2 square is greater than r square, then it is outside the circle. If it is equal to r square, x square x2 square is equal to r square, this is going to lie on the circle, right? So this is going to lie on the circle. Now this is basically going to be your equations here. Now if I have to extend the same thing to, let's say, a sphere, right? So a sphere, if you can think of it like a ball, right? Now I can easily extend it by stating that x1 square plus x2 square plus x3 square is equal to r square. Quite simple, right? You can see that I can even extend it to ND plane if I want to. That's basically, I will call it as hypersphere. Hypersphere. Now if I have to talk in hypersphere, I can say x1 square plus x2 square till my xn square is equal to r square. So that's the beauty about linear algebra. You can basically start from a 2D dimension, keep on moving to multi dimensions, and this can be very easily defined by all these mathematical equations.